Welcome to EDU World Space.
Since these three resistors are in parallel, so the total resistance should have the relation that 1 over R is equal to the sum of 1 over each resistance, which are 1.6 plus 1 over 2.4 plus 1 over 4.8. Okay, so from this equation, we can know that total resistance should be equal to 0.80. And since they are in parallel, the voltage on each one of them should be equal to the voltage of the battery, which is 28 volts. So the voltage on each one of them is 1, V1 equal to V2 equal to V3 equal to 28 volts. So the current goes through each one of them. So the I1 equal to V1 over R1 going to be equal to, so V1 is 28, R1 is 1.6, it's going to be equal to 17.5 ampere. Similarly, I2 equal to V2 over R2 equal to 11.7 ampere. And similarly, I3 equal to 5.8 ampere. So this is for question A, this is for question B. For question C, the total current is just the sum of these three currents, which is equal to 35.0 ampere. Or you can just directly calculate by the total voltage divided by the total resistance, and you will get the same answer. Okay. For question D, okay, so as we described here, the voltage, they equal each other. So V1, 2, and 3, they all equal to the voltage of the battery, which is 28 volts. Okay. As for the power, P equal to the current times the voltage on each resistor. So it's also equal to, since we have the Ohm's law, V equal to IR, we can also write this as V squared over R or I squared times R. So all these three descriptions are equal, okay? So P1, the power on the first resistance should be V squared over V1 squared over R1, which is 490 volts. Similarly, P2 gonna be equal to 327 volts. P3 gonna be equal to 163 volts. And the last question. So if we look at this expression here, they have the same voltage. So if they have the larger resistance, they have less power. They have less resistance, they have more power. So in order to get the maximal, in order to get the largest power, you should have the minimal resistance. So R list